Hey, geometry. Today we're going to look into 1.5 angle pairs. There we go. There we are. All right, so we've got all these different angle pairs and features of them. So the first one is the most general. Adjacent angles are two coplanar angles with a common side. They share a side and a common vertex and no common interior points, so they don't like overlap. Interior points. All right, so an example, if I have an angle like this, an adjacent angle would be that. So we could call this, the easiest way to label those would be 1 and 2. And so angle 1 and angle 2. So angle 1 and angle 2 are adjacent angles. All right, vertical angles are two angles whose sides are opposite rays. And this is an important one. So if I have an angle like this, the vertical angle would be if I take that ray from that same point and go in the opposite direction, and this one go in the opposite direction. So really it's just kind of continuing the line. Sorry, that should be a straight line. That's a pretty bad drawing there. All right, these two angles, angle 1 and angle 2, so angle 1 and angle 2 are opposite rays, or sorry, are opposite angles. Vertical angles, they have opposite rays. But there's another pair here. If I label this 3 and 4, so are angles 3 and angle 4 are also vertical angles. A key feature of vertical angles is that they are congruent, which means that the measure of those angles is the same. This angle has the same angle measure as that vertical angle, angle 2. Angle 3 would have the same measure as angle 4. All right, complementary angles are two angles whose measures sum up to 90 degrees. Each angle would be called the complement of the other. If we have a 90-degree angle, this is one way we could show this. If I have a right angle, if I split this up here, then angle 1 and angle 2 are angle 1 and angle 2 would be complements of each other. They add up to 90 degrees, but they don't have to be in a right angle together. If I have one angle that's, say, 42 degrees, and let's call this A, we haven't used A yet, angle A, and then if I have another angle that is a little bit bigger at 48 degrees, if I add those two up, they add to 90 degrees, and so those angles would be complementary as well. 42 plus 48 is 90. So angle A and angle B would also work. And we can just label those with a single letter because there's no other angle that could be confused with that. Remember, otherwise we would have to use 3 points. We might say, like, whatever, the point here, A, and then the other point. All right, and then supplementary, the last angle pair we'll look at, those add up to 180 degrees. They make a straight angle when kind of put together. Each angle is called the supplement. So for example, if I have a straight line here and I split that up with a couple of angles, angle 1 and angle 2, angle 1, this is a lot of the same thing here, angle 2, are supplementary angles. They add up to 180. I don't have to know their measure because when I see them next to each other, they make that straight line, which would be a 180 degree angle, a straight angle. But we could also do it with others. Say I have one here that's 78 degrees. All right, and let's call that A again. And then this other one could be 102. 102 degrees. Those add up to B, and if I rotate them around and put them together, we can make a visual like that. But those two are supplementary, so angle A and angle B. All right, so identifying some of these in these examples, identify some adjacent angles. Well, there are a lot of adjacent angles here. We could say angle 1 and angle 2. I'm just gonna do a little plus sign. That's really not proper, but I'm gonna write a few of these. We could say angle 2 and angle 3. We could say angle 3 and angle 4. We could have said angle 4 and angle 3 as well. It doesn't matter the order. Those are all adjacent angles. 4 and 5, 5 and 1. All right, I'll leave it there. ... Vertical angles. We actually only have as labeled one set of vertical angles here, and that would be angle 3 is vertical with angle 5. Angle 3 and angle 5. Those are vertical angles. 4 would be vertical with like the combination of 1 and 2, but since that's not labeled, I won't do that. Complementary angles, angles that add up to 90 degrees. Well, I don't see any right angles here. We're not going to eyeball it. So there are none that are obvious in that. So it doesn't appear that there are any complementary angles in that set. But supplementary, we could say we have a straight line here, 3 and 4. Angle 3 and angle 4 are supplementary. They would add up to 180 degrees. And then we could say the same thing about angles 4 and 5. Those angles are supplementary as well, those pairs. And that's that. So then over here, we're kind of identifying, we're going from example angles to their definitions. So angle AFE, this 62 degree angle, and EFD, those are a couple of things. They are, I'll write this down. I'm not going to write this down for everyone, but they are adjacent. But maybe even more so, they are supplementary. They make that straight line. These two, if you add those up, it adds to 180 degrees. So they are adjacent and supplementary. All right, next one. Let's talk about angle AFE, that same 62 degree angle, and then BFC. All right, they touch at a point, but they're not vertical angles because these lines have to go, even though this one goes straight, this one would have to go straight here to make it like a vertical angle. We can come over to what that vertical angle is in a second. But BFC, we do notice 28 and 62, those do add up to be 90 degrees. So those are actually complementary. Angles. Next example, we've got angle BFC. So BFC, this 28 degree angle, and CFD. It's hard to eyeball. It looks like a right angle, but can we be sure? So what we need to do here is actually use another feature to figure this out. So one thing we could have realized right away is that this angle AFE is vertical CFD, and so that is a 62 degree angle as well. At this point, I can see that BFC and CFD are complementary. They're also adjacent and complementary. But you can't just like eyeball it. You can't say, oh, that looks like a 90 degree angle. So remember, these aren't drawn to scale. So we need to be able to actually see it in the measures in the proof of what we got done. Just seeing an angle and thinking, oh, that does look like 90 degrees. It should either be labeled or we should have an angle measure to show so. And then finally, AFE and CFD, AFE, CFD, that's actually the one we just used, the idea that this would be 62. That is vertical.